Go.
Hello.
Hello, Mr. Eric, Mr. Ryan. How are you today? So today we talk about intersection of two arrays. Keep quiet, please.
Okay.
So previously we talked about the intersection of two linked lists, right?
Yeah.
The principle is quite similar. The approach we've taken today is quite similar. So let's take a look at this example. Okay. 1, 2, 3, 4,
5, 6,
Okay,
7,
and then
8, 9,
3, 4, 5, 6, 7.
8.
So what's the intersection of these two arrays? Hmm?
1, 2, 3.
Well, there's no one here. Intersection,
Oh,
the common
3.
elements. 3.
4, 5.
Okay. So these are the unique numbers. How about if I tell you that I add another 3 here, and
3.
it's still 3 should appear once or twice?
3 times.
No.
Once.
Once, yes. How about if I put another, and how many 3?
2.
2, 3. So I need to put 3 here, right? Alright?
Yeah.
So it's the intersection, the common parts, and if they are duplicate numbers, you should only have the minimum, the less number that appears. Because look, if 3 appears once here, appears twice here, then in the intersection there will be only 1, right?
Yeah.
If there appears 3 times here and 2 times here, so how many times I should put it here?
2.
2 times. 2 times. Okay. What's the
One consonant.
I'm not asking anything. What's the approach to tackle this problem? Yeah, notebook. How do we use the notebook?
You look it up.
Look it up. If we are not using notebook, how are we going to tackle this one? Brute force. How do we brute force?
Checking everything.
Checking every number going through each number on the first array, and then check if they appears in the second array, right?
Yeah.
So for example, like 1, and I go through the second array, and how and to see if it has a 1. So if this is n, this is m element. What's the term complexity?
N times n.
N times n. Yeah, that's because for each n numbers, I need to go through the second m element to check if it appears here. And there's also one thing to note is that how are we dealing with these duplicate numbers? For example, if there are 3, and then you find a 3, right? And then you put a result in 3 in the result, but you need to remove the 3 from the second number, so it doesn't count the next time when you have a 3. Got it? Yes? Am I right?
Mm-hmm.
How about if you don't look? If there are 2 3s and there's only 1 3 here, if you don't remove it, what happens? 3 it appears here. You put a 3, and then 3 appears here again. You put another 3, but which is wrong, yeah? It's incorrect because it only appears once in the second array, right? So how do we fix this? Is that when we're going through the first array, we find immediately, as long as we find it in the second array, we put it in the result and we remove it, yeah? Alright? Does it make sense?
Yeah.
This is brute force. So it's all n times m. And you're mentioning we can use the notebook, right? The notebook is good for the lookup. What's the term complexity?
One consonant.
Yeah. But we need the n time to put it in the notebook, right? If there are n apples, yeah? We want to put it in the box.
I love apples.
Yeah, good. And then it needs the n times, right? So if we put it into the notebook, so we also need to remember how many times it appears in the array, right? Yeah, we because for example this one 3 3, we need to have a notebook saying like, okay, 3 appears twice, right? Yeah, am I right? Notebook. So we can go through this like this is numbers. Then we can say for I. This is notebook. Okay, then we can say notebook dictionary default dictionary, which is the type of integer, and then for I in nums. And then we can do this notebook I
think you forgot
plus equals 1, right? Yeah?
Yeah.
But all these can be converted into what? Remember we're talking about a magic class in Python which can count the number of elements and how many times they appeared in an array. What's the object? Start with C. O. C O U.
Count.
Counter. Yeah. So all these can be turning into notebook equals counter. We want to count what? Count the numbers.
Yeah.
So these three lines is exactly the same because that's the same thing for you. Okay? So when we have the counter for these two, counter which is the notebook, when we have the counter for these two arrays, then we can go through the keys, the number of the notebook, and then appears it and append the same numbers in the result. Okay? So let's do it. Define, let's say intersection or
Column.
intersection.
Column.
Okay, then array 1.
Column.
Let's say A, B, column.
Column. Yeah.
Okay, so you tell me, okay, the notebook 1, notebook A equals counter, yeah? A. And notebook B equals counter B. Okay? So now these two lines just count how many numbers in the array, in both array, right? And then put it in the notebook. Okay, then now we go through one array of each, yeah? For I in notebook A, right? Now we know, then this I, for example, is 3, and we want to find out if 3 is in notebook B. How can we do it? Harry? If
You merge.
no, if I what?
You sort it.
Sorry, if this I is in the notebook A, and I want to find out if this number is also in the notebook B. So how can we do it? If I what?
If I
In what?
nouns. No, B.
Notebook B.
We
So this number appears in both. Now at least here, this number appears in both array, right?
Yeah.
So what do we do now? If this number appears 3 times in the first array and appears 2 times in the second array, so what do we do now?
Pretend on one side they're half and the other side they're half, and you're trying to make a whole apples.
Okay, so we want to put the duplicate numbers, in the common numbers in this answer. Okay, so if the 3 appears 2 times in the first array and then 1 time in the second array, so how many times of 3 we need to add it in the answers?
Yeah.
It minimum.
Minimum. Okay, so look, for let's say for in range, we want to put it in the minimum, so that's mean. Yeah, we call the mean function. And notebook A I, yeah, this is the number of times appears in the first array, and notebook B I, right? Okay, the mean function, and then we do this answer dot append what? Append which number? Look.
I.
Yes. Yeah, I appears in both array, and then we want to find the minimum. Yeah, minimum of, and I is the number of times, which is 2 times here, and bi, which is 1 time here. Get the minimum. Yeah, and append I, and return what?
Return answer.
Well done. Good job.
Yeah.
What's the time complexity?
Owen.
No,
Something.
Owen, go again.
Suddenly not.
Stop guessing.
We're not guessing.
And if it's the in the first, and A, if the n
A
number,
plus B. No,
B
no,
is
no, no.
the M is the number of element in the B. So how many times we need to go?
O-N
Oh, and
square times N.
do we come?
O-N.
M.
Yeah, because we
Where's
look,
M?
M is the number
Oh,
of
I thought
elements
that
in
was
the B.
B or A.
Okay. M. So why is that? This look,
Why is that?
look. We're going
You
through.
can say A plus B.
Yes, look. This is the.
And I said that.
Okay, it's the same
Nah.
thing. Okay, I'm gonna say.
No.
Or A plus B. Okay, if you prefer. Okay, so this going through.
Healthy.
Building this NA takes A time, yeah, or A time. Building this MB takes OB time, right? Yeah, OA plus B. And then we're going through these elements in the number of, in the array of A. So in this case is in the worst case this is OA time as well because there are A elements in the array, right? And the notebook has this OA time, right? This is A iteration. And then we check if it in node B, this is O1 constant. Yeah, we're talking about checking something in the notebook is O1 constant, and we're we're just adding it. It doesn't. This may look another 4, but actually, if you think about it, it only has 1. Okay? Yeah. Okay, so can we use the previous methods to the same similar algorithm? You know, moving the two linked lists. Remember? Remember? Yeah? Remember this linked list thing. This is A, this is B. And how can we do this?
We put the last one together and then keep on going.
We keep on going.
Oh, pretend A has half and B has half and you're trying to make a whole. Wait, if A has half of an apple and B has half an apple and you're trying to make a whole apple and then
Put them together.
yeah, how many apples?
First of all, these two.
You take away half of each one, then put, and the arrow's still there.
2 pointers.
And
2 pointers, yeah, exactly. So look, in order for this algorithm to work, we need
2 pointers.
2 pointers. But this linked list needs to be sorted. Am I right?
Yeah.
Needs to be in range. Look.
There are.
Then yeah, look. 1 smaller than 2. So should I move 2 or 1?
1.
2 and 2. Okay, it's the same. So we add
You rub it out.
We add it and then we move it together. 3 equals 3. Yeah.
Yeah. 4 equals 4.
Yeah. And then when this one, any of these is beyond the end, then we call the end. Okay. Yeah.
So it's 23 points.
Like 2 and 3. Okay. So for
2,
example,
3.
so we can apply the numbers. Look, first of all, we need to sort the array, right? If the array is not in order, we can apply this 2 pointer, right?
Yeah.
Alright. Does it make sense?
Yeah.
Okay. So look, 1. If we sort it, 1, 3, 4,
9.
9. Okay. And then this one, let's say 3, 9, 7. 3, 9, 10.
And
Okay, look, this is array, a result, answer. 1 and 3. 1 is smaller than 3. Should I move 1 or should I move 3?
1.
3 and 3 equal, right?
Yeah.
Let's put another duplicate number, 3 here. Okay. And then I'll put another 9 here and another 9 here, okay? So 3 and 3, put it 3 here. And I need to move both, yeah?
Yeah.
3 and 9, move 3 or 9.
3,
4 and 9, move 4 or 9.
4.
9 and 9, okay? Put the 9 here. And then move it to both. Again, 9 and 9, right? You see? So it handles the duplicate numbers perfectly. Got it?
Yeah.
Okay. Define, okay, let's just do it F, A, B. What's missing?
Column.
Okay, A dot sort. Okay? We're sorting this. What's the time complexity of sorting an array? Oh, what?
N.
Oh.
Something.
Oh, and times what?
M.
No, there are
N.
there are n elements in the. We talked about this before.
Sort.
Yeah.
N
Oh,
log n.
yeah. This is the
Yeah.
time
That's my
complexity.
favorite
Okay.
one.
B
I
dot
love
sort.
O1.
Alright. And answer equals. We're putting the common elements in the array. Okay. Then look, I equals j equals 0. Okay. They're pointing. Eric, what's I equals j equals 0? What does it mean?
I is 0, J is 0.
What's I and what's j? We want
2 pointers.
2 pointer pointing to the beginning of the 2 array, right? Okay. Let's say A comma B equals len A len B. So what does it mean here? Eric? LA equals LA comma LB equals length.
AB equals LB.
Yeah. LA comma LB equals length A length B. What does it mean?
It means
What does it mean? You don't know this syntax? AB equals, look, we talk about this. AB equals 1, 1, 1, 2. What does it mean? A equals 1.
A equals 1, B equals 2.
Here it means what?
A equals length A, B equals length B.
LB equals length B. Okay, so it's the length of that. Okay, then now we can do this. While I smaller than LA and J smaller than LB. Okay, this is dying. Okay.
Dying.
The pen is dying. Okay, so look, what does it mean? What's this mean? I smaller than LA and J smaller than LB. Why?
Then you move it.
So why any of these are still in the range? Yeah. Okay, if AI equals BJ, what should I do? If the same equal, what should I do? If the two are
You
same.
move both of them.
But before that, we should put this number in.
I-
So answer, yeah? Answer the what?
Answer
What a pen.
A pen. Yeah, good job. You're paying attention.
Yeah!
AI and then moving. How do we moving? I what?
I
shift. No.
J I what? J what? 1 here.
add equal. Yeah, I'm paying attention.
Okay. Else if AI smaller than BJ, so what should I do here?
What's Elif?
If is else if. Okay.
Elif.
Yeah, you write else if you only write you erase this you write it if. Okay, so shorter. AI smaller than BJ. What should I do? I move what? Move I or move J?
Wait. Let me think.
3 and 5.
I.
Okay, so how what?
I add equals 1.
And here else what?
J add equals 1.
Okay, and then
Yeah,
and return what?
Return.
Return what?
Return.
What are we doing here? Return what?
Answer.
Yeah, write down. What's the time complexity? What? This is O n log n. This is O
OA.
m log m. Okay. And here is what? Here is O m plus m. Okay. Yeah.
So what does that equal?
Sorry.
What does that equal?
Good question. So look, this part of algorithm is O m plus m because we are visiting all the elements from the both two array, right?
Yeah.
These two parts in the sorting, I told you, sorting the A elements, O n log n, sorting the another array, m O log m. Okay. So you add it together, but you discard the trivial ones. You know the trivial one, the small one, smaller part, which is this part. Yeah. This is smaller than this. Yeah. Yeah.
Yeah.
So the algorithm, the time complexity is O n log n plus m log m. Okay? Got it? Or if you prefer, you can probably you can merge this, but I wouldn't do it. If there are same array, if there the number of the elements in both arrays are the same, then we can just do O n log n, right?
Yeah.
Okay.
You can just.
That will be simple because the overall complexity is dominating by sorting. Yeah, this takes most of the time. This is trivial, right? Yeah. If we don't need the sorting, then the time complexity we need to find out. We need to point out is O n plus m, right? Yeah. So for the algorithm complexity, we always pick the most time-consuming part, right? Yes, and we discard the constant, right? All right. O2n is the same as ON. Or 100n is the same as ON. Got it? Because 100 is a constant. Got it? Yes? So okay, so this is the pretty much for today. I'm going to erase one of it, okay? So let's see. You're not looking! You're not looking! You're not looking. Okay, I'm erasing here, okay? So okay, write here something and here something.
B dot sort.
Okay. And then?
BJ?
Yeah.
Yeah.
Okay, that's it. Very well done today. Very well done today. You want to say bye-bye to people?
Bye.
Bye. This is my own home.
Yeah.
My own.
Okay, bye-bye. See you tomorrow.
Blah, 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 blah.